Okay, this is lesson 1.6, Advanced Math Notes 1.6. And we're going to call this, or title it, Rational Expressions with Negative Exponents. Simplify. Number 1. X to the negative 1 minus y to the negative 1 over x to the negative 2 minus y to the negative 2. All right, remember we talked the other day on one of these lessons, I think it was the last lesson, 1.5, where you are not allowed to flip-flop these or move things up and down in this fraction. Like kids will try to say, can I just move things up and down? That x to the negative 2 comes up, that y comes up, that x to the 1 goes down, and that y goes down, and that is a big fat no. So please, please, please be careful. Do not make that mistake. All right. They're negative exponents and there's plus or minus signs in between. You will have to make separate fractions. For example, 1 over x minus 1 over y all over 1 over x squared minus 1 over y squared. And this is review from what we did on 1.5, the 1.5 lesson. You change everything individually, 1, 2, 3, 4 separate fractions. And then we go through and clear our complex fraction by multiplying everything by the common denominator. Again, we're clearing a complex fraction by multiplying everything by the common denominator. We're not multiplying only by what's missing, we're multiplying everything by the same thing. That's because I have a big complex fraction and I'm trying to clear it. And I'm hoping you guys all realize that it's x squared y squared is my common denominator. X squared y squared on every single term. So x squared y squared at the top, x squared y squared at the bottom to everything. And when you do this, things should clean up. Okay, so x reduces, x squared becomes x. So that is xy squared. Take away, the y's reduce, y squared becomes y, x squared y, over x squared reduces, that's y squared, minus y squared reduces, and that is x squared. Now factor to see if factoring allows us to reduce. I can see that there's a GCF up here and a difference of 2 squares at the bottom. Pause if you'd like and factor on your own and then double check when you're done. Okay, I took out a GCF of xy. xy times y is xy squared. xy times negative x is negative x squared y. Difference of 2 squares. I can see that these here are not opposites. They are exactly the same. They're just simply going to cross out. No negative 1 is coming out to the front. So my final answer is xy over y plus x. Or x plus y if you want to change that. Okay, I'm going to quickly put an or here and we're going to do the same problem just a different way. Now the reason I'm showing you this different way is because this method does work nicely on some of them. This particular problem either way would be perfectly fine, but most of the ones you're going to do today, this method is going to work really nice, and I just want to make sure you understand you have other methods. The other method is to factor first, and I did talk to you about that on yesterday's lesson. I will tell you right now, there are some problems where factoring first does not work out nicely, and there are some that do. So try it and see if things reduce. If it reduces, then good, you go forward. If it doesn't reduce, then factoring first is not a good idea. Okay, so up here I simplified my negative exponents, and then I cleared my complex fraction, and then I factored and reduced. Where here I'm going to factor first, reduce, and then I'll do this step at the end. Let me show you what I mean. X to the negative 1 minus y to the negative 1, and then I'm going to double bubble the denominator. And I can see that's difference of two squares. Only thing is I have negative exponents. So negative 1, negative 1, negative 1, negative 1 on my x and my y. This is going to give me x to the negative 2. This is going to give me negative y to the negative 2. All right, and then if you can see here that this works out nicely for these two to, these two to reduce. They are exactly the same. And that leaves me with 1 over x to the negative 1 plus y to the negative 1. Now, it would be nice if we could be done here, but you can see that I have negative exponents, which I need to address. 1 over x plus 1 over y. I cannot just push these up to the top because there's a plus sign, which means two separate fractions. If it helps you, make this top a fraction as well, and that was one thing I did say, make everything a fraction. 1 over 1, 1 over x, 1 over y. 1 over 1 is equivalent to 1. Clear by multiplying everything by the common denominator, and your common denominator being xy. So 1 times xy is xy. Here the x is reduced, you're left with y, plus the y is reduced, you're left with x. This is your final answer, and you can see it comes out to be exactly the same thing. On this particular problem, either way works out nicely. Some of you might figure this works out as quicker, and you'll do it this way, and that's perfectly fine. I believe most, if not all, the ones you do today when we, or on this particular lesson when we do it in class, work out nicely. They all factor and reduce, and then you clear up your negative exponents at the end. We will see some the day after where they do not work out nicely, and we will get more practice to recognize when should you factor first and when should you not factor first. All right, let's continue. Number 2. am negative 1 plus an negative 1 plus bm to the negative 1 plus bn to the negative 1, and then m all over m to the negative 2 plus n to the negative 2. Okay, I could make 1, 2, 3, 4, 5, 6 individual fractions, and if you want to do it that way, you're perfectly fine. I'm going to factor first just to show you, because I haven't done a whole lot of them that way. Just that last one was the first one. So I want to show you how to do it with factoring first. Again, if you, when I'm done, if you want to pause it and try it the other way, that's up to you. But I'm going to see that I have factor by grouping here. My GCF here is A, m negative 1 plus n negative 1. If you'd like, you can hit pause and finish off the rest on your own, and then check. GCF of B, m to the negative 1 plus n to the negative 1. I'm going to finish off that numerator piece. I'll do this denominator after. All right, and then I could see that at the numerator I have a GCF. My GCF being the m to the negative 1 plus n to the negative 1. So I factor that out. Times, and what's left over. And then this is not difference of two squares, because I did write that incorrectly. Sorry to those of you who are working ahead and got stuck. That should be a minus. Again, my apologies, that should be a minus, which makes it a difference of two squares. M, n, the plus, m minus n, and I do need to make my exponents negative so that they do add up to the negative 2 when I multiply. Okay, let's reduce. I can see that this is gone completely, and that leaves me with this here, a plus b over m to the negative 1 minus n to the negative 1. I cannot stop here. I'm not allowed to because I have negative exponents, and because of the plus minus signs, I'm not allowed to just push it up. I have to make individual fractions. I'm going to do the bottom first. 1 over m minus 1 over n. At the numerator, I'm going to make that a fraction. Your choice, I'm going to erase, so if you're writing in pen, don't write yet. You can write it as a over 1 plus b over 1. Or, the way I'm going to write it, just because I personally like it better, a plus b all over 1. It is the same thing. It's totally up to you and how you want to write it. But all I did was I made my numerator a fraction by putting it over 1. A plus b all over 1. And then I multiply top and bottom to clear my complex fraction. And I do that by multiplying everything by mn, because that is my common denominator. Oh, and I put an extra one, got carried away. Already had it there and didn't realize. All right, so I'm going to do the bottom first only because I can see that things reduce. M is gone, so that leaves me with n. Minus n's gone, and that leaves me with minus m. Now the numerator, and I've talked to you about this before, I typically do not distribute because I want to leave it in factored form to see if anything reduces. So typically I don't distribute because then I would distribute and then GCF it to see if anything reduced. So I just don't distribute. I leave it in factored form and I look to see if anything reduces, and since it does not, this is my final answer. And just a quick reminder that someone else, you, your friend, or a test writer could distribute and get AMN plus BMN, and it is still the same answer. All right, I don't care if you write it this way or this way, just know if it's a multiple choice test and you write it this way and the test writer writes it this way or vice versa, you know they are the same thing. Okay, number 3. 45 parentheses x to the negative 1 minus y to the negative 1 to the third power all over 54 times x to the negative 2 minus y to the negative 2 in parentheses times the quantity of x to the negative 1 minus y to the negative 1, close parentheses. Again, the ones that you're going to see on this assignment tomorrow are all like this, where they work out really nice to factor. You factor, reduce, and at the end take care of your negative exponents. They'll all work out that way. The next lesson, the one we're going to do tomorrow, will show you some where it doesn't work out nicely this way, and we're going to talk about how to recognize it. For now, let's just factor, be happy, reduce, and move on. Okay, this is already in factored form for me. 45 times this, 54 times this, everything is factored. So I'm going to go straight to reducing. What goes into 45 that also goes into 54? 9. So 45 divided by 9 is 4. 54 divided by 9 is 6. And let's see what I have. These two are not the same, but these two are. These two, they're the same factor, so I can reduce. This is to a power of 1. This is to a power of 3. You can think of it as subtracting your exponents. These two have like bases, and when you're reducing like bases or dividing in a fraction like bases, you subtract the exponents. All right, so this one's gone completely where this one is now raised to the second power. This one's gone completely, and this is now to the second power, because if I wrote 3 of them out, one of them would have crossed out with this one here. All right, so that leaves me 5 parentheses x to the negative 1 minus y to the negative 1 squared all over 6 parentheses x to the negative 2 minus y to the negative 2. Okay, now right now as I was writing this, I'm thinking, what am I going to do with this exponent right here? I can't reduce these, and I can't like move things around with that squared being there. If that wasn't there, I could make 1, 2, 3, 4 individual fractions and then clear by multiplying by the common denominator. But that squared being there, I cannot. So I'd like you to think for a few seconds. If you need more time, you can hit pause on what we can do to fix this, like what can be done. I'm hoping you recognized it is factoring. I can factor this guy right here using difference of 2 squares. And the top guy is going to stay x to the negative 1 minus y to the negative 1 quantity squared. X to the negative 1 plus y to the negative 1, x to the negative 1 minus y to the negative 1. Now this one, there really was no other way other than to start reducing, factor, and reduce. You couldn't change everything to fractional exponents from the get-go because of that third power or second power. So we were forced to continue factoring to reduce. All right, I can see that these two are the same, which means I can reduce. This one's gone completely, and then 2 minus 1 is 1, so this new power is 1. And this one's gone completely. There's squared here, meaning there's 2 of them. There's 1 here. I reduced 1 set, so I'm left with 1 at the top. 5 parentheses x to the negative 1 minus y to the negative 1, and it's now to the first power, over 6 parentheses x to the negative 1 plus y to the negative 1. And these two are not exactly the same. I cannot reduce them because that has a plus, that has a minus. They're not opposites. Yes, these two are opposite, but the x's are not opposites. Therefore, these two pieces here are not opposites of each other. All right, therefore, at this point, I can't stop because I have negative exponents, so I'm forced to clear. I'm going to cover these guys really quick. How many individual fractions are you going to end up with? I can erase that there. You can leave it. It's not necessary. 1, 2, 3, 4. Now, I can't make these fractions and start to clear complex fractions with those guys in the front, just like I couldn't with that squared. Lucky for us, that reduced, so now I have a power of 1, a power of 1. But unfortunate for us, the 5 and 6 are still there. So I will have to distribute them in order to clear my complex fraction. Well, it's going to become a complex fraction. All right, so all I did was distribute 5 to both, 6 to both. Now you can see I really truly can make 4 separate fractions. Now when I do that, you want to be careful that you recognize that this x to the that negative 1 is only being applied to the x. So what is the 5 going to do? Move or stay? It's going to stay. So 5 over x minus 5 over y. Go ahead and rewrite the denominator. Six over x plus 6 over y. So these are the pieces that go to the denominator of your individual fractions. The 5 and 5 stay, the 6 and the 6 stay. And now we do what we've been doing and clear by multiplying everything by the common denominator. And the common denominator being xy. Okay, x's reduce. That leaves me with 5y plus y's reduce. That's 5x over x's reduce. That's 6y plus y's reduce. So that is 6x. Okay. Can I reduce right now the way it is? No, but I can factor and see if factoring allows me to reduce. And typically we like to factor just in case. And I know I messed up on my signs right here. Apologies, that should have been a minus. So if you were wondering, what the heck, how did she get that plus? I was just going too fast. All right, 5 parentheses y minus x over 6 parentheses y plus x. Nothing does reduce. Again, I discussed it earlier. These are not opposites of each other. This here is the final answer. And I've said it enough times by now where I'm hoping you recognize, since factoring did not allow me to reduce, if you had left it like this, you would be okay. Typically, we factor just to make sure, but test writers might leave it like this, and you should know that is the same. All right, that's it for this lesson.